As most of you probably are aware, autism is a lifelong neurodevelopmental disorder that affects about 1 in 31 children in the US. And it is characterized primarily by challenges with social communication and interaction and restricted and repetitive behaviors. And it being a neurodevelopmental disorder, its onset is in early childhood. So the average or the median age of first diagnosis in the US is currently estimated at 47 months. And that's really when behavioral signs become very apparent. The general consensus, though, is that neurodevelopment in autism starts to diverge in early infancy or even already in utero. Yet most neuroimaging studies in humans have been conducted in much older children and adults. So there's very few studies actually in this critical infant, toddler, and preschooler period when autism typically gets diagnosed. And that's maybe not surprising because acquiring high quality MRI data without the use of sedation in this age range is incredibly difficult. Kids in that age, they don't stay still, and that's very detrimental to our MRI data quality. So the only way to really do it is to do it at night when they are asleep. And then hopefully don't move. So I moved to San Diego. Oh, let me see. Okay. So I moved to San Diego in 2016 to work with Dr. Ina Fishman. And just starting then SDSU toddler MRI study. So this is a study enrolling children ages 15 months to 5 years with and without autism, and they come into our Center for Autism and go through a comprehensive diagnostic and developmental assessment, and then we try to do an MRI scan with them at night during natural nocturnal sleep. Now, any one of you has ever met a toddler probably is aware that that's not a super easy task either. So we go through a lot of preparation with the families. We send them home with a social story and with earplugs to practice, and we play the scanner noise to the kids so that they get familiar with that. But still, it's pretty, you need a lot of patience. It's not an easy task. To date, we have enrolled around 260 children. And we've managed to get successful MRI scans from 70% of the children in the autism group and almost 90% actually in the typically developing kids. And what is really great is that in the kids with autism, whether we manage to do the scan is not related to their autism symptom severity or their developmental skills. So on the right here, you can see a plot of where the kids in our cohort fall on the Mullen scales of early learning, which is the developmental assessment that's correlated with later IQ. It's normed at 100. And you can see that we really get a really broad range of developmental skills in the autistic group, which is great because it means we can do much more inclusive MRI research, which is not at all true for studies in older children and adults, which is usually much more heavily biased towards kids at the more typical level of cognitive function. And then also, because we are scanning these kids asleep, they have to be really, really deeply asleep in order for us to be able to do it. And that means that once they are that deeply asleep, they don't move. And so we get really high data quality, and we don't actually see any group differences in data quality between these two groups, which is also pretty rare. When you scan older kids and adults, usually the kids with autism move a lot more, and that is a confound for our analyses. So that's great. You might have noticed when I showed you the slide earlier that our scan success rate is a little bit lower in the autism group. And what became apparent really early on when we started the study was that a lot of parents were telling us how their kids had trouble sleeping, not just during the scan or for the scan, but in general, and that this is really a major concern for the families. And we didn't discover this. This is not new. Sleep difficulties are very common in autism. They affect 60 to 90% of individuals with autism compared to 15 to 25% in the general population. And you all know probably, a bad night of sleep, what that does to your daytime functioning, to your learning, executive function, mood. And so if you have bad sleep every day, you can see how that really affects your quality of life. And so it's really unfortunate that we don't really know what's causing these sleep problems in kids or adults with autism. And there's currently no evidence-based treatment for sleep problems in autism either. There's many reasons why somebody with autism might struggle to sleep, and some it's linked to co-occurring ADHD or oppositional behaviors or the medications they're taking. But what I'm focusing on today, just showing you some results from our study, is a link between sensory hypersensitivity and sleep problems, which has been a little bit overlooked. Sensory sensitivities are also extremely common in autism. And in fact, since the DSM-5, they are part of the diagnostic criteria. And multiple studies, including one of our own, have shown that children who have more severe sensory sensitivities also tend to have more sleep problems. Intuitively, that makes a lot of sense. If you are very sensitive to sound, you can see how that might make it harder for you to fall asleep or wake you up more often at night. But what we really don't know is why are these kids more sensitive to sound and why does that interfere with sleep? And if we can answer those questions, maybe we'll be able to develop some more targeted treatments or interventions specifically for those kids that show this combination of symptoms. So when you're asleep, your brain is still responding to sensory stimulation, but that response is a little bit attenuated. And so what we think might be happening in children with autism is that the brain, especially the sensory regions, are hyper-excitable. And so that's true both when they're awake and asleep, but when they're asleep, that might actually interfere with their sleep. And there's some good evidence for this in auditory cortex specifically, from animal models of autism and also in adults from studies that used EEG or MRI spectroscopy, so slightly different imaging methods than we have been using. But in 2020, Tarkosic et al. And Brett Wojtek at UCSD, they showed in a really elegant paper that you can extract a measure, a proxy measure of excitation-inhibition balance in the brain using fMRI as well. And I'm not going to go into details of these methods here. We applied this to our toddler MRI data. The only thing I want you to take away from this slide is that this measure that we're getting, the Hurst exponent, it's a little bit counterintuitive because a lower value actually reflects higher excitability. So what did we find in our data? So this is from the toddlers, and so this is now just the ASD group actually because in the TD group we didn't have enough children where the caregivers reported that they wake up very easily from noise. So this is showing that amongst the kids with autism, those for whom the parents report that they're more likely to wake up from noise have a higher excitability in their primary auditory cortex. So now we have a pretty objective measure of their brain's hyperexcitability, but the measure we're using to assess sleep problems in these kids is pretty crude, right? It's a very subjective measure. It's really just a yes-no question. And so what we have been doing since then is we have started a follow-up study in slightly older children, so these are 6 to 12-year-olds now, and we sent them home wearing a little watch that tracks their sleep for 2 weeks, a little bit like an Apple Watch. And so we get much more objective measures of sleep from this watch. And interestingly, or great for us, what we see in this group of older kids is that these kids with autism also show more excitability of their auditory cortex when we scan them, awake this time. And across groups, so this is actually true in the typically developing kids too, we find that higher excitability of their auditory regions is related to lower sleep efficiency. And in this case, sleep efficiency is a measure we get from the actigraphy that combines, like it tells us how often the kids wake up at night, but also how long it takes them to fall asleep. It's like it takes both of those into account in its estimate. So this is quite exciting. So we have now seen in 2 independent cohorts, different age ranges, that auditory cortex hyperexcitability is related to sleep disruptions in young children with autism. And we really do hope that this will give some motivation for some more intervention research to test whether any, we know that there is medication that can address some of those hyperexcitability aspects. But we also know that there's sensory modifications that can be done maybe to help these kids that show this combination of symptoms. So yeah, we really hope this will give some impetus for more intervention-style research. And I also hope that I've convinced you that natural sleep MRI is possible in toddlers and preschoolers and allows for more inclusive neurodevelopmental research in very young children with autism that can yield very meaningful measures of brain development. And with that, I want to thank everybody at the Brain Development Imaging Lab. This is a huge team effort. I've not done this research on my own. I want to especially thank Dr. Ina Fishman, who was brave enough to start this endeavor, and our toddler team, and Dr. Rakesh Bhattacharjee, who is the head of pediatric sleep medicine at Rady, and obviously all the participants and families who participated in our research. And this is really just one example of the findings we've had from our toddler study. So if you're interested to learn more, go to our lab website. Or if you're ever interested in participating, we do study the brain across the whole lifespan. We have participants that are over 70 years old, so reach out.
The sensory sensitivity, like why did you look at sound first? Like, were there other questions about like fabrics and things like that?
I mean, the easy answer is they are asleep, right? And so there's a limited number of modalities we can test. We could presumably like rub something on their arm, or test whether having a weighted blanket on or not makes a difference in their responses. But sound is really the easiest modality to present when they're asleep. The other reason is that, well, my whole career I've been studying auditory processing. So I have a long-standing interest in better understanding how we process sounds and how that relates to language development and now to sleep disruptions. And also sound, sensitivities to sounds are one of the most common in autism. A lot of kids are also adverse to certain touch, but it's often what people report first. You often will see kids, right, wearing the headphones or, so.
Yeah. I'm curious to know if in preparation for the trials, you have them practice with earplugs in.
Yeah.
Do parents report any improvement in sleep after that, perchance?
We know that some kids really like the earplugs. Yeah. What is one challenge with the kids is that they easily fall out, right? So in the scanner, we can put in the earplugs, and then we put headphones, and we put foam cushions around them to hold them in place. It's harder at night to, but I would assume they do help. And we know that some kids actually use there's a company that makes these much prettier earplugs that hold in ear slightly better. Loop, they're called, I think. And they're really popular with some of the kids we have seen, yeah. The bigger challenge is that some of the kids are also very, they don't like having something stuck in their ear at that age, right? So if they're still awake when you try it, they just pull it out. Which goes along with, there's also a lot of sensitivity to touch. And some kids, in some of the kids where we have failed to scan them, it wasn't actually because they're so sensitive to the noise or can't fall asleep. They just wake up the second we put the earplugs in. Even if they're really deeply asleep, some kids just have another sense where they're like, don't touch my ear.
I was curious if you were talking about how the self-reporting, like from the parents, may be a good measure, but maybe in some types of studies that's all we have.
Yeah.
Kind of thing. So I was curious if you looked at the extent to which the watches, how well that correlated with what the parents were saying, as like a way to test how valid this.
So some of it does correlate. There's studies on this too. So some measures actually do correlate pretty well. So we often use the CBCL, the Child Behavioral Checklist, and it has a sleep problem subscale. And there's a whole paper about this, of how that T-score that you get doesn't actually correlate very well with actigraphy or polysomnography. But there's an individual item on it that just asks, does your child have trouble getting to sleep? And this individual item correlates very well with sleep latency that you can get from the watch. So it really depends on what exactly you're looking at. We have discovered, so the kids wear the watch, but we also have a sleep diary that they fill out. And so we can see even how well that corresponds to the actigraphy. And people are really bad in estimating how often they wake up at night, for example. Often, in older kids, it's also the parents might not even know when the kid woke up, right? Or maybe they're just drowsy, they have their eyes open, they move around a lot, but they don't really remember that they woke up. So yeah, it really depends on the measure itself. Some are better than others. I don't know.
A lot of what you described sounds very familiar to the patients we work with with chronic pain.
Yeah.
Who also have a lot of sleep problems. And so I'm wondering how specific you think
Yeah.
these deficits are to autism versus
Yeah, I don't actually think it's specific to autism, really. I think it's more common in autism than in the typical population. But I think that relationship between sensory sensitivities and sleep issues is not specific to autism. No, I mean, and you see, this correlation is basically the same in our typically developing kids and the kids with autism. And 15 to 25% of the general population also report sleep problems, right? Insomnia is incredibly common in older adults too. So no, there's a no, I don't think it's specific.
and your tests of auditory cortex, they're evoked tests, or is it resting right now?
No, this is just from resting state MRI. We actually do play the kids' sounds too while they're in the MRI scanner because we are interested in how early auditory development relates to language outcome. So that's what the study was initially designed for, actually, our toddler study. So we have that data too, and we see pretty large group differences in that too.
Briefly, the beauty of this is, and you're raising an excellent point, the beauty of this is that it's very mechanistic, and this excitation inhibition balance that you talked about, in other words, the neural hyperexcitability holds through for pain.
Yeah.
Chronic pain, for other,
Yeah.
for long COVID, for example, neuroinflammatory disorders.
Yeah.
And so it holds a lot of explanatory power, and I think it's really wonderful from that perspective. But
Yeah.
if you can just, I know it's not a part of your study, but besides this hyperexcitability, is there sleep architecture disturbed? K complexes and spindles and whatnot.
There are some studies that show that. We should talk about writing in your grant. But there are some very few actually. There are studies that have done polysomnography in kids with autism. So the kids go to a sleep lab where they wear EEG and they sleep in the lab for a night. And so yes, we know that there is reduced sleep spindle activity in kids with autism. So yes, again, what makes autism tricky, or any mental health disorder really, is that there's a lot of heterogeneity, right? We go grouping kids by behavioral symptoms, right? And so the etiology is very different for different kids, and so I think there's a lot of overlap with other disorders, and so some of these kids might have co-occurring circadian rhythm disorders too. And we have seen some of these kids that their circadian rhythm is just completely shifted. They go to bed at 4 in the morning and wake up at 2 p.m. That's a different type of sleep problem than taking longer to fall asleep, right, or waking up a lot. And so grouping them all together, actually Rakesh, our collaborator at Rady, hates it when we say sleep problems because it's not one thing, right? There's so many people might say, my child has problems sleeping, but what does that mean exactly, right? And so you have to really distinguish. And so how much these measures that we're getting from MRI relate to what is being seen on polysomnography, for example, would be super interesting. Our first paper that ventured into the sleep field actually looked at thalamocortical connectivity, and so that's one of the most well-replicated findings in autism, that there is over-connectivity between the thalamus and sensory cortices, which is thought to probably be related to differences in sensory gating, so probably also related to this, but we need to do a lot more research to really figure out what goes with what, right? And that will hopefully then help us to really subtype kids where we can target their interventions much more towards that, towards treating that. Yeah.
Thank you very much.
Thank you.